In this video, we're going to begin discussing one-to-one functions. First, let's review what a function is. So a function is where every element in the domain corresponds to only one element in the range. In other words, each x value only gives one y value. And that's what you would probably want from a function. If you have an equation for a function and you substitute in an x value, you usually only get one y value, right? Because we're usually dealing with functions when we're substituting x values into equations. So, for example, if this is one function f, each x value is only showing up once in the table, and so each x value is only giving one y value. Here's another example of a function, right? Each x value only shows up once next to one y value. So both of those are functions. Now what we're going to be talking about in this section is a specific type of function called a one-to-one function. So we're still talking about functions. We still have each x value giving us only one y value. But if we're getting more specific and talking about a one-to-one function, then the reverse is true. For a one-to-one function, each y value is only coming from one x value. That's not true of every function. That's what makes it a one-to-one function. This function f here is one-to-one, so the y value of 3 only shows up once, the y value 4 only shows up once, and the y value 5 only shows up once, so that one is one-to-one. Here though, we see the same y value coming from different x values, so that one is not one-to-one. So they're both functions because every x value only shows up once, but this one's not one-to-one because the same y value shows up more than once. We can look at it with just a set of points written out like this as well, and then we're going to kind of tie this into what we're looking for if we see a graph. So here we have a function that just has 4 points, and each y value is the second coordinate in the parentheses, and this y value of 2 is showing up twice. So this one's not one-to-one. But here, each y value only shows up one time. So that one is one-to-one. If we graph these, there's just going to be 4 points on the graph, so we're not going to connect them because then we'd be drawing in more than 4 points. But just to kind of do a quick sketch here, so we have 0, -1, we have 1, 2, we have 2, 3, and we have 3, 2. And then we'll go ahead and draw in the second one here. So we have the point 0, 12, 1, 8, 2, 4, and 3, 0. Okay, now let's look at the difference between these two graphs because the first one is not a one-to-one function and the second one is. What made the first function not one-to-one was those 2 points that both have a y value of 2. So these 2 points right here. Two points that have the same y value will fall on the same horizontal line, because a horizontal line is a line where all the points have the same y value. So if you can draw a horizontal line through more than one point on the graph of a function, it's not one-to-one. Whereas down here, if we draw a horizontal line anywhere, it's not going to hit more than one point. So that means the function is one-to-one. And so that's what we call the horizontal line test. If you can draw a horizontal line through more than one point on the graph, then the function's not one-to-one. It's similar to how we had a vertical line test to determine if a graph represented a function in the first place, right? The vertical line helped us find the duplicate x values, which meant it wasn't a function. The horizontal line is going to help us find duplicate y values, which just means the function is not one-to-one. So, just to give us some examples here, and you can pause the video and copy the graphs down first if you like. If we look at the first function here, it's just a straight line, and anywhere we draw a horizontal line, it's not going to pass through more than one point. So we don't have any duplicate y values. We can't find 2 points on that line with the same y value. So this function is one-to-one. My drawings aren't the best, but this is our x cubed function. So we've got just this curve that's increasing from left to right. So anywhere you draw a horizontal line there, it's only going to hit 1 point. So that one's one-to-one. This one is a function we're going to see in probably the next chapter or the chapter after that. But anywhere we draw a horizontal line here, we're only passing through 1 point as well. And then here's our square root function. So sometimes you can draw a horizontal line that doesn't pass through any point. That's fine. But you don't want to be able to pass through more than 1 point. Otherwise, it's not one-to-one. So all of those are one-to-one. Down here, if we draw a horizontal line there, for example, we just found 2 points with the same y value. So that one's not one-to-one. That one's a parabola, right? So any parabola is not going to represent a one-to-one function, no matter whether it opens up or down, where it's located, how skinny or wide it is. You're going to be able to find 2 points on the parabola with the same y value. So those are not one-to-one. Here we have our absolute value function. Those are not going to be one-to-one, because you can find 2 points with the same y value there. And this function, which we're going to see in the next chapter as well, has 2 points with the same y value. So that one's also not one-to-one.